A parabola is the graph of a quadratic relation. The basic parabola has the rule y equals x squared. The basic parabola is y equals x squared. Everything is 0 and the turning point is a minimum. When I say everything is 0, it means the y-intercept is 0, the x-intercept is 0, the axis of symmetry is 0, etc. Simple transformations of the graph of y equals x squared include dilation, reflection, and translation. Dilation occurs when the coefficient x squared is changed. For example, when the coefficient of x squared is 2, the parabola becomes skinnier, but if the coefficient of x squared is half, it becomes wider. Reflection occurs when the coefficient of x squared is a negative. When it is a negative, the parabola has a maximum turning point. When it is a positive, the parabola has a minimum turning point. Translation occurs in the example y equals in brackets x plus 3 squared. When that is the rule, the parabola's turning point is on the negative 3 x-intercept. Translation also occurs when the constant is changed to a negative number. For example, in the rule y equals x squared take 3, the turning point is moved down the graph on the y equals 3 y-intercept. But if it was to be y equals x squared plus 3, the parabola would be moved into the plus 3 y-intercept. If all that information is put together, the rule y equals x squared is then changed to y equals in brackets x take p in brackets squared plus q. Therefore, the entire graph moves p spaces to the right and also q spaces up. That rule is known as the turning point form. The point where a graph crosses the x-axis is called the roots, or x-intercepts. We calculate the roots of an equation by factorizing the equation, or completing the square, or using the quadratic formula. In the equation y equals x squared plus 3x take 4, you can equate to y and make it 0, and factorize the equation and you'll get y equals x take 1 in brackets times x plus 4 in brackets. You take the numbers out of the brackets and you'll get x1 is equals 1 and x2 equals negative 4. Basically, when general form is factorized, you get the equation y equals in brackets x take d times in brackets x take e. Therefore, the roots are going to be in brackets d comma 0 and e comma 0. Therefore, the graph crosses the x-axis at 1 and negative 4. In the equation y equals 8x squared plus 14x plus 3, since this equation is a non-monic trinomial of the form ax squared plus bx plus c, you'd have to times the coefficient and the constant, the coefficient being 8 and the constant being 3. Therefore, you would get 24. Since you got 24, you'd have to give a number that adds to give 14 but times to get to 24. Therefore, you get 2 and 12. The equation is then changed to look like y equals 8x squared plus 2x plus 12x plus 3. You then factorize 8x squared plus 2x to get 2x in brackets 4x plus 1. And you also factorize 12x plus 3 and you get 3 in brackets 4x plus 1. The equation now looks like 2x in brackets 4x plus 1 plus 3 in brackets 4x plus 1. You then add the 2x and the 3 and you put them in brackets and you go 2x plus 3, and then since 4x plus 1 is the same, it goes in brackets 2x plus 3 in brackets 4x plus 1. Then you have to solve that new looking equation, and let's just do the in brackets 2x plus 3 first. So you get 2x plus 3 equals 0, then you want to take the 3 from the left side and put it on the right side, so you get 2x equals negative 3. Then you want to divide both sides by 2, which will give you x equals negative 3 over 2. So x1 is negative 3 over 2. Then we go back to looking at the equation and we see the other one is 4x plus 1 in brackets. We solve that, so we get 4x equals negative 1, and then we divide both sides by 4, and we get x equals negative 1 over 4. So the roots are x equals negative 3 over 2 and x equals negative 1 over 4. Now let's look at an example where we have to complete the square. Let's say y equals x squared, take 12x plus 7 equals 0. So then you're wanting to halve the b value, which is negative 6, and then you're going to find the square root of that, which is 36. So you're going to make your equation look like x squared, take 12x, plus 36, take 36, plus 7 equals 0. Then you're going to want to factorize x squared, take 12x plus 36, and get, in brackets, x take 6 squared. Then you're going to take 36 and add 7, so you get take 29. The equation then looks like, in brackets, x takes 6 squared, take 29, equals 0, because we're trying to find it out. Then you want to get the take 29 and put it on the other side and make it positive 29, so it looks like, in brackets, x takes 6 squared equals 29. Then you're going to get rid of the, in brackets, x takes 6 squared and make it x takes 6 equals plus or minus the square root of 29. Then you put the negative 6 on the other side and you'll get x equals 6 plus or minus the square root of 29. Then you just solve that and you get x1 equals 11.39 and x2 equals 0.61. Those are the roots of the equation y equals x squared, take 12x plus 7. Looking at the equation x squared, y equals x squared plus 7x plus 5, you can use the quadratic formula, which is x equals negative b plus or minus the root of b squared, take 4ac, all over 2a. In this case, a is 1, b is 7, and c is 5. Therefore, you just put it in the equation, you get x equals negative 7 plus or minus the root of 49, take 20, all over 2. Then you just simplify that down a bit more and you get x equals negative 7 plus or minus root 29 all over 2. Then you just solve that and you get x1 as negative 7 plus root 29 all over 2 and x2 as negative 7 take root 29 all over 2. And yes, those are the roots of the equation y equals x squared plus 7x plus 5. The point where a graph crosses the y-axis is called the y-intercept. The x value of every point on the y-axis is 0. To find the y-intercept, you need to substitute x as 0 into any of the forms. It can be the general form, factorized form, or the turning point form, as long as you substitute x as 0. In the equation general form y equals x squared plus 3x take 4, you can make x 0, therefore you would get x squared, which is 0, plus 3x, which is 0, take 4. Therefore, the y-intercept is negative 4. In the factorized form equation, y equals, in brackets, x plus 9 times, in brackets, x take 10, you substitute 0 as x, and you'd get y equals 9 times negative 10. Therefore, you would get y equals negative 90, and that is the y-intercept. In the turning point form equation of y equals, in brackets, x plus 3 squared, take 9, as you substitute x as 0, you get y equals, in brackets, 0 plus 3 squared, take 9. Therefore, you'd get 3 squared, 9, take 9, and then you get y equals 0. Sketching the graph of a quadratic is different from plotting the individual points. It does not have to be to scale, and you should leave the axes without a scale. It is the shape and location of the key points that are of interest. In summary, by completing the square, all quadratics in the form y equals ax squared plus bx plus c can be expressed in turning point form. Turning point form is y equals, in brackets, x take p squared plus q. To sketch a quadratic in the form y equals, in brackets, x take p squared plus q, follow the steps. Determine the coordinates of the turning point, which is P and Q. If there is a number out the front of the brackets and it is positive, the parabola has a minimum turning point, meaning it goes like a U shape. When the number outside the brackets is a negative, the parabola has a maximum turning point, like an upside down U, so a sad face. You can determine the y-intercept by substituting x equals 0 and determine the x-intercepts, if any, by substituting y equals 0 and solving the equation.